Good day, students. I am Mr. Ibarola and I am going to introduce the course outline of General Mathematics. So the first topic is all about function. So what is the student learning outcomes? So first is we will represent real-life situation using function, including the piecewise function. Next, evaluating a function. Next is, we will perform addition, subtraction, multiplication, division, and composition of function. And the last is, we will solve a problem solving involving function.
Today, I will be discussing you operations on functions. You can obtain a new function by adding, subtracting, multiplying, and dividing functions. Accordingly, these new functions are called sum, difference, product, and quotient of the original functions. I'll give you example. Suppose you are given h of x is equal to x squared minus 5 and k of x is equal to 2x minus 11. Let's try to apply the different operations. Say for example, you are asked to find letter A, h plus k of x. What does this mean? This means that you will be adding the value of h of x and k of x. H plus k of x is the same as h of x plus k of x. Get the value of h of x, which is x squared minus 5 plus the value of k of x, which is 2x minus 11. So how do we add? We just add similar terms. So h plus k of x is equal to x squared plus 2x, then add negative 5 and negative 11, which gives you negative 16. Therefore, h plus k of x is equal to x squared plus 2x minus 16. Okay, let's have example B. Suppose you are asked to subtract h minus k of x, and that is equal to h of x minus k of x. Same process, just get the value of h of x and k of x. That is, h minus k of x is equal to h of x, which is x squared minus 5, minus k of x, which is 2x minus 11. Take note that you need to enclose the subtrahend in the parentheses because you are going to change the sign of each term, then proceed to addition. So, h minus k of x is equal to x squared minus 5, then I will be changing positive 2x to negative 2x, and negative 11 to positive 11. Add the similar term, h minus k of x is equal to x squared minus 2x, and negative 5 plus 11 is positive 6. Therefore, h minus k of x is equal to x squared minus 2x plus 6. Now let's try multiplication. That is, h times k of x is equal to h of x multiplied by k of x. Replace h of x with x squared minus 5 times k of x, which is 2x minus 11. You can use here the FOIL method. So x squared times 2x is 2x cubed. x squared times negative 11 is negative 11x squared. Negative 5 times 2x is negative 10x. And negative 5 times negative 11 is positive 55. Since there is no similar terms to combine, this is already the answer. H times k of x is equal to 2x cubed minus 11x squared minus 10x plus 55. Okay, letter D. H divided by k of x. H divided by k of x is equal to h of x divided by k of x. Again, replace the two functions. H divided by k of x is equal to h of x, which is x squared minus 5, divided by k of x, which is 2x minus 11. Since there is no factor for the two functions, hence, this is already the answer. Let's have another set of functions. We have f of x is equal to 2x squared plus x minus 3. And g of x is equal to x minus 1. Suppose you are asked to find letter A, f plus g of x. Letter B, f minus g of x. Letter C, f times g of x. And letter D, f divided by g of x. Let's have f plus g of x. F plus g of x is equal to f of x plus g of x. Same process, replace each function with a given value. So f plus g of x is equal to the value of f of x, which is 2x squared plus x minus 3, plus g of x, x minus 1. Combine similar terms, f plus g of x is equal to 2x squared plus x plus x is 2x. Negative 3 plus negative 1 is negative 4. So the answer is f plus g of x is equal to 2x squared plus 2x minus 4. Letter B. We have f minus g of x, and that is equal to f of x minus g of x. F minus g of x is equal to 2x squared plus x minus 3 minus x minus 1. Let's combine similar terms. So f minus g of x is equal to 2x squared, x minus x is 0, negative 3 plus 1 is negative 2. So the answer is f minus g of x is equal to 2x squared minus 2. Letter C. We have f times g of x, and that is equal to f of x times g of x. F times g of x is equal to 2x squared plus x minus 3, which is the value of f of x, times the value of g of x, which is x minus 1. Here we use the distributive property. F times g of x is equal to 2x squared times x is 2x cubed. X times x is x squared. Negative 3 times x is negative 3x. 2x squared times negative 1 is negative 2x squared. X times negative 1 is negative x. Negative 3 times negative 1 is positive 3. Next, we are going to combine similar terms. F times g of x is equal to 2x cubed x squared minus 2x squared is negative x squared. Negative 3x minus x is negative 4x plus 3. So the answer is f times g of x is equal to 2x cubed minus x squared minus 4x plus 3. The last one is f divided by g of x equal to f of x divided by g of x. We have f divided by g of x is equal to 2x squared plus x minus 3 divided by x minus 1. Here, we can factor out 2x squared plus x minus 3 to 2x plus 3 and x minus 1. So, f divided by g of x is equal to 2x plus 3 times x minus 1 all over x minus 1. We can now cancel x minus 1 in the numerator and in the denominator. Therefore, f divided by g of x is equal to 2x plus 3.
Good day, students! So for today's video, we will be talking about composition on functions. So last topic, we already discussed operations on functions, namely addition, subtraction, multiplication, and division. Our topic for today is somehow a continuation of the previous one. Let us now discuss composition on functions. Another operation which involves functions is obtaining the composite functions of two given functions. Given two functions f and g, the composite function denoted by this symbol, read as f composed with g, is defined by f circle g of x is equal to f composed with g of x. To further understand that, let us have examples. Let us have example number 1. Given, if f of x is equal to 3x squared minus 4x and g of x is equal to x minus 1, find the following. A. F circle g of x. B. G circle f of x. And C. F circle g of negative 2. Let's begin with example A. Let's have example A. F circle g of x is equal to f composed of g of x. First step, identify what is the first function. The first function is function f, which is 3x squared minus 4x. The second function is function g, which is x minus 1. Next, write the respective value of the function f. Then replace or substitute all the variable x in the function f by the function g. F circle g of x is equal to 3 times the quantity x minus 1 squared minus 4 times the quantity of x minus 1. After doing such, next, expand the first term containing parentheses x minus 1 squared. That is x minus 1 multiplied by x minus 1. Then use FOIL method. Multiply the first term, that is x multiplied by x, x squared. Next outer term, x multiplied by negative 1, negative x. The inner term, negative 1 multiplied by x, that is negative x. Then the last term, negative 1 multiplied by negative 1, that is positive 1. After that, combine similar terms. X squared, negative x, that is negative 2x, then positive 1. Then go back to the original function. 3 times the quantity of x squared minus 2x plus 1 minus 4 times the quantity of x minus 1. Next, use distributive property. Distribute 3 to x squared minus 2x plus 1. That will be 3 multiplied by x squared, that is 3x squared. 3 multiplied by negative 2x, that is negative 6x. Then 3 multiplied by positive 1, that is positive 3. Next, distribute 4 to x minus 1. 4 multiplied by x, that is negative 4x. Then negative 4 multiplied by negative 1, that is positive 4. Again, combine similar terms. 3x squared, negative 6x, then negative 4x, that is negative 10x. Positive 3, then positive 4, that is positive 7. Then, if there's no more similar terms to combine, that's the final answer. Easy, right? Let's try another example. Example B. Let's have example B. G circle f of x is equal to G composed of f of x. Again, first step, identify what is the first function. This time, function G is the first function, which is x minus 1. Then second function is function f, which is 3x squared minus 4x. Then, write the respective value of the function g. After that, replace or substitute all the variable x by the function f. That is 3x squared minus 4x minus 1. If there is no more similar terms to combine, that's already the final answer. Piece of cake, right? I told you. Let's have example C. F circle G of negative 2 is equal 3x squared minus 10x plus 7. Based from the example A, we already solved for the composite function of f composed with g of x, which is 3x squared minus 10x plus 7. For this example C, all we have to do is replace or substitute all variable x by negative 2. That is f circle g of negative 2 is equal to 3 multiplied by negative 2 squared minus 10 multiplied by negative 2 plus 7. After that, simplify negative 2 squared, which is positive 4. And negative 10 times negative 2, which is positive 20. Then, plus 7. 3 multiplied by 4, that is 12, plus 20 plus 7. Simply combine similar terms. Add 12, 27. That will be 39. Therefore, the final answer of f composed with g of negative 2 is equal to 39.
Let us try solving word problems involving functions and piecewise function. Let's have number 1 problem. A t-shirt costs 120 pesos. What is the cost of 7 t-shirts? So let's have the solution. So let x be the number of t-shirts. So that would be f of x is equal to 120x. Why 120x? Simply because for every purchase of t-shirt, it's equivalent to 120. After that, replace variable x by the number of t-shirt to be purchased. That would be f of 7 is equal to 120 times 7. F of 7 is equal to 120 multiplied by 7. Hence, f of 7 is equal to 840. Therefore, the cost of 7 t-shirts for 120 pesos each is 840. Okay, let's do problem number 2. A boat ride in Lake Villa Resort will cost 500 pesos, intended for 15 passengers only. 50 pesos per head is charged for additional passengers. What is the total boat ride if there are 18 passengers? Use a piecewise function to represent the boat ride fare. In terms of piecewise function to the given problem, we will be having two sub-functions. Sub-function 1 is f of x is equal to 500 for the specified domain. That is, if the value of the variable x is greater than 0 but less than or equal to 15. And sub-function 2 is f of x is equal to 500 plus 50 times the quantity of x minus 15 for the specified domain. That is, if the value of the variable x is greater than 15. Going back to the problem number 2, since problem number 2 pertains to 18 passengers, that means the value of the variable x is greater than 15. Therefore, we will be using sub-function 2, which is f of x is equal to 500 plus 50 times the quantity of x minus 15. Next thing you will do is to replace all variable x by positive 18. That would be f of 18 is equal to 500 plus 50 times the quantity of 18 minus 15. Next thing to do, simplify first the term inside the parentheses. That would be f of 18 is equal to 500 plus 50 times the quantity of 18 minus 15, that is equal to 3. Therefore, f of 18 is equal to 500 plus 50 multiplied by 3. Simplify, f of 18 is equal to 500 plus 50 times 3, that would be 150. Adding or combining similar terms, that would be f of 18 is equal to 650. Therefore, the total boat ride fare for 18 passengers is 650. Problem number 3. An online shop located in Manila charges a shipping fee inside or outside Manila. They charge an initial shipping fee of 100 pesos for orders with a total amount of 400 pesos and below. An additional 50 pesos shipping fee for orders with a total amount between 400 and 800 pesos. And a double initial shipping fee for orders with a total amount above 800 pesos. Letter A. Write a piecewise function representing a shipping fee charge in pesos for the total amount of orders. And letter B. How much shipping fee will they charge if the total amount of orders are 500 pesos? So let's have A first. For letter A, write a piecewise function representing a shipping fee charge in pesos for the total amount of orders. So based from the given problem number 3, we will be having 3 sub-functions. So let's have sub-function 1 is f of x is equal to 100 for the specified domain. That is, if the value of the variable x is greater than 0 but less than or equal to 400. And sub-function 2, f of x is equal to 100 plus 50 for the specified domain. That is, if the value of the variable x is greater than 400 but less than or equal to 800. And the last subfunction, subfunction 3, f of x is equal to 100 multiplied by 2 for the specified domain, that is, if the value of the variable x is greater than 800. Clear for letter A? If that's so, let's have letter B. So for letter B, the question is, how much shipping fee will they charge if the total amount of orders are 500 pesos? So since based from the problem, the total amount of orders are 500 pesos, that means the specified domain is greater than 400 but less than or equal to 800. Therefore, we will be using subfunction 2, which is f of x is equal to 100 plus 50. So, simplify, f of x is equal to 100 plus 50, that is 150. Therefore, they will charge 150 pesos for shipping fee for the total amount of orders, which is 500 pesos. Any more question about composition and functions? If you have any queries about the topic, feel free to ask your respective teachers. So, for the next topic, it will be all about finding the domain and range of a function.